guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. I'm dying here. Yeah, your eyes aren't deceiving you. There's two fans on top of each other here. And I'm just curious. Now they say curiosity killed the cat. Let's see what's going on here. Okay. So bottom fan we're using the lights, or the top fan we're using the lights, and the bottom one's actually doing work. Huh. Well, we'll have to come back and fix that. Yeah. Yeah. So, gentle and kind friends and sirs and ladies, what we got going on here is a absolute no name. There's like literally no name on the amp, so we have no name on the manufacturer. But it's put together like a Stickman-esque amp. And I say that because of the combiner circuit. And, the splitter circuit and the combiner circuit. This is very interesting to me. Look at this. I've seen chicken poop make better sense. Now this one here, we know this transistor, the lid has been super glued back on. We can see the super glue and that, the writing on it's cocked over, but there's no 10 ohm resistors. The input's all burned up. Output's all burned up. Now, the gentleman that owns me, this is part 2 in a 2-part series, is a gentleman by the name of Mr. Frank. And he was suggesting to me that I scrap that eliminator 1x4 I just repaired. And I said, no, we're not doing that. Eliminator's a good little box. And I said, it'd be cheaper just to come around and fix this as it stands. Now, what we've got going on here is we've got Toshibas. Okay. So Toshiba transistors now cost about $105, $110 a piece. Okay. The replacement transistor that we're all hot about right now, the HG 2879 1608, we're having a little bit of a hard time getting them right now. Our good friend in China that's manufacturing those is having a hard time getting them into the United States for whatever reason. So, as like I was telling Mr. Frank, I've got these parts, and it makes more sense to come back and just rebuild this as it stands than it would be to strip that other amp and then rebuild this. There's a bunch of stuff going on here I don't care for, like the ground and the positive lead. I mean, like really. So we got to replace the positive rail. Gonna have to replace the negative ground wire. And there's a whole bunch of other stuff in here I want to do. So first things first, let's clean these out. I have a feeling that this one's bad too, because it's been yarded out of here a couple times, it looks like. And we're going to go back through and we're going to make this a little bit more style, not my style. Now, the problem with this style of combination and splitting is that it's so high in induction, you can get the watts out of the amplifier, but it's not very efficient. So when we go to measure this thing, we're going to want to keep our eye on the amp meter over here. And the reason we're going to want to do that is, let's say your standard 8-pill is going to make 2,000 watts of power, let's say, peak power, right? And it's going to do that on maybe about 200 amps, right? Something that has this level of combiner and splitter network in it and is this high in turns and induction, we'll find that it's going to pull about 270 amps versus the 200. And we'll also notice that this thing gets incredibly hot. These amps have a tendency to run hot. They still work. They pull them a little bit more current. They make the same amount of power. So I'm not saying negative about anybody. I'm just like, no, we need to address that. We need to think about that. We need to go into that with our eyes open. So knowing that going forward, I'm going to go ahead and I'm going to do the strip down on this thing. I do like the use of the RG400 on the input and the RG400 on the output. That'll never fail. decent size relay. But I'm going to go in here and I'm going to start ripping stuff out. That's not the reason this failed. Apparently one of these transistors must have gone bad, and I mean, that's just, oh well, it don't matter. It ain't gonna look that way for long. So let me do my magic, pull these transistors out, pull most of these satellite components out. We'll probably have to lift this one out of here as well and test it. And that's about where I'll be when we come back. I'll have this resistor out, that resistor out. We're gonna have these power leads off. We'll have the transistors out, and the pill pockets, this whole area, this whole zone will be all cleaned up and looking a lot better and ready for us to reassemble. So on that note, see you all in a minute. Oh, super glue. Ah, it's burning my eyes. Yuck. Ah. There it is. Come on. Okay. All right. Now we're about half dead from the super glue fumes. Yeah. Junk. It's the one that was next to it in the chicken poop. Imagine that, it's also junk. Ugh. Alright, well, let's pull this third one out. Because it looks like it's been accosted. So you have to ask yourself, what caused the transistors to go bad? Did a cap go down? Or what? Get overdriven? I don't know why we had to pull all three, or why they pulled this other one out. You can tell just by looking. Well, no, it does have a different 10 ohmer, doesn't it? Yeah, it's got its own little special 10 ohmer in here. Different style, different. Oh well. Nothing I ain't seen before. Gain of 16. Alright. Well, the pills are out. Alright, let's wash it and clean it up. We'll be back. So, we got the pill pockets all cleaned out, got the power wires out of it. And if we look down here, we'll see this pill strip is charged. Chooched and charged. So now what I gotta do is I gotta very carefully cut this little piece of pill strip out, and then I gotta cut another one to match it, and then I gotta groove it and fit it in here. I can't just solder over that. That's too big of a hole. There's a little bit of a hole on this pill strip here, but I'm pretty sure I can fold the phenolic back over and salvage it along with this one and this one as well. That's too much. I got to clean that up. I'm very interested to see how this thing is going to run once we replace these two transistors. Just a little curious. So, yeah, let me get this cut and get this replaced. I got to pull the input transformer off, and then we'll put down a new piece of pill strip, 2 new 10 ohms, and put the input transformer back down. So that's where we're at. Well, so I had the whole thing rebuilt, and I put in these 2 transistors, and it was shallow and way up in power, like way up in power. And the output capacitance wasn't right for this circuit, so I added output capacitance to it. I was sitting there running it, and all of a sudden I went from making like 18, 19, 100 watts of power down to like 400. So I popped 2 of my own pills, so now I'm sitting there pulling this whole thing apart, and I am not seeing anything that would cause these transistors to go bad. So I'm checking all these caps. Last thing I got to check are these 2. And then I want to look at this inductor choke. But it didn't burn the pills up. It just, or the 10 ohm resistors, it just popped the transistors. Boop, popped them. So something's not right. I got a piece of broken ferrite or some cap that's way out. So, I'll get back to you when I know some more. Well, that took some doing. I had to strip the whole dang 2-pill section completely apart. The input transformer had one too many wraps on it. And that's why these 2 transistors kept getting frickin' flaccusade. So I ran out of non-red dots. I put red dots in here. It doesn't really matter. This is impressive to me with this circuit. That's a 1,000 watt slug in 2x position. Oh, 600 bird and 1,000 watt peak. Input reflect is good and low. Way better than what it was. We had to adjust this capacitor. They had 2 150s here. And what helped it the most was adding these supplemental 330s, which gets us into the 310 range, 320 range, or pardon me, 1010 to 1015 range on the output transformers. So that helped a bunch. It just had straight 680s on here. I did add the balancing resistors to the splitter and the combiner circuit. Went through and put all new 5 waters in this thing, cleaned up all the solder joints inside this box, redid our power bus, our ground bus over here in the corner, replaced this with a stainless steel nut. It had a nickel plated thing in there. Replaced your power wire with something substantial enough to carry the current. Zip tied everything up, put flex loom around this to keep it from rubbing against this copper. I gotta do the fan. I put a body plug up here in this hole that's in the front. That should just about finish it out. I just tickled this thing's running. 2,000, 1,800. And nothing is screaming hot. I'll put resistors on the balancing circuit. Cool. Cool and cool. So I'm going to key it a bunch more, and I'm just going to sit here and play with it for a little bit. I'll be back. Well, we just ran this for about a half hour. I am not seeing any problems with this thing. It's running like a Swiss watch now, so I'm going to let it leave. Now what I did do is I took these 2 fans out and replaced it with one single fan at about twice the CFM. So fixed the LED, replaced the 2 bad transistors, and redid all the solder work. Tested this transistor, it's still good. Replaced the power wire, it's still good. Added 5 watt resistors on the input and the output to make those circuits balanced. Changed the input tune so it was nice and low and clean, ready to go. Added 330s to the output transformers to actually make the circuit step up and put out the right amount of power. And when I mean it runs, this thing is really running well. So, now that we know all of those things, ourselves onto the test mode stage of this little adventure. This has been fun, but popping those 2 transistors doesn't make me too happy, but that's my own fault, and being a repair shop, you got to absorb your losses like that when you make mistakes. I throw a couple screws in this thing just so we got a decent ground to run the fan. There we go. Let's put one more in it for safety's sake. I don't know who built this box originally. I have no clue. But I'm going to put a label on it that says 8 pill repaired by, and then I'll slap my sticker on the front of it. So. Alright, that's a 1X. Let's run around the lap here real quick. 1000 watt slug in peak, 1000 in average, 5 watt slug in reverse back from the bird, 10,000 watt dummy load. We're going to use the bench 2 pill with a 50 watt slug between the 2 pill with a 3-foot jumper going into the 8 pill. We're running off the bench power supply, so we're going to look at that amp gauge. Using a 2950 and the 5 watt slug between the 2950 and the 8 pill. The one thing I didn't show on camera was me cleaning up the pass-through. The pass-through on this box was way out. It was like a 4 SWR going through. So I added a capacitor to ground on the relay. So now it's less than a 1.0. Let's see, amplifier's off. So let's start. There's our 20 watts going through. That's our pass-through. And what I'm demonstrating to you is that if the radio wasn't able to talk through the relay smoothly, you would show up as a large quantity of reflect there. Now, let's go ahead and do our spectrum shot. That's the principal. There's the amplifier. Now to keep from blowing up the amplifier, or keep from blowing up my spectrum analyzer, we're going to go ahead and shut this down. Shut that guy off too. Now, this does move quite a bit of air. And remember how I said in the beginning of this thing that this particular circuit, the way this circuit is laid out in here, it's not the most efficient. So it does have a tendency to make the box run a little bit hotter. So we've got a little bit higher CFM fan in this thing. Okay, so now we're in a 1X position, and we're going to put 20 watts of drive in this box. 900 watts. About 300 peak. Look at our amp gauge. Now remember, what we're looking at is the input reflect down through all of this stuff into here. So half a watt going in reverse is not too bad. So let's go ahead and we're going to turn on the drive on the little 2 pill, the bench 2 pill. Let's show you what we're putting into this thing for drive. About 220 watts. That's all you need to hit it with. Let's just go ahead and take this to the 2X position. 2,000 watts in the corner. Let's back our dead key down a little bit. Gotta go higher than that. So, about 200 watt carrier. Input tune. Amp draw. That's not nearly as bad as I thought it would be. About 160 amps. 130 to 160 amps. This thing's running. It's running real good. So now let's go ahead, shut that off so I'm not deafening everybody. And it's not that loud. You just got to remember the proximity of the microphone to the vent and the fan is really close. So let's go ahead and we're going to hook up the derail radio now. Let's turn this up a little bit. 200 bird, about 300 or 400 watts in. Now we're not seeing the peak watts, but look at the average meter. Going forward. That's too much. Turn the variable down on the 2-pill. Really should quit keying it like that. It's hard to key the amplifier that high. Let's do it like that. There's about a 200 watt carrier. Laying it in the corner. Look at the amp drop. Almost 300 amps. Now, the average guy is not going to see that performance. I say this quite often. It's a little bit warm. The average guy isn't going to see that level of performance unless he's got himself a derail radio. I say this all the time. We're not going to see them huge bird numbers. That's why I use the regular Joe Schmo off the street radio to show everybody, okay, it's going to make 500-600 watts a bird. But we all know an 8-pill is really running and running good if we're going to see around 1,000 watts out. Now, I just dead keyed this thing at 800 watts plus. Don't do that. That's hard on the box. It's hard on the transistors. It'll cause you problems in the future. So just keep your dead key down around a couple hundred watts and have fun talking on it. So let me do the last little bit of this. We'll just put some stickers on it, and we'll be back here for the wrap. We're back on the 2950 real quick. I wanted to show you this. 800 bird on a regular Joe Schmo amp radio. 220 watts worth of drive, or 220 amps worth of current consumption. I'll call that good. Honestly, I was thinking about it here just a second ago, and I thought, man, I don't remember if I showed what it was doing for average power with the 2950 hitting that thing. So we picked up 400 watts or so, but it was slamming that needle in the corner. I'm done dicking around with it. This thing is good to go. Frank, I think you're going to enjoy this thing when you get it on your side of the street. All right, let me put some stickers on it. Well, put an on-off, put the on label on there. Went ahead and put a BBI sticker on it because it is a repair. Put an 8-pill repair sticker on it because, well, otherwise somebody will claim I built this. You just never know how this goes in this world, you guys. Like, I had a cat. I used to sell these stickers, right? I thought it was cool. And I sold this cat like 8 stickers one time. And then about a week after I sold the stickers, all of a sudden there was 8 or 9 BBI repaired amplifiers on eBay that I'd never touched, seen, or anything. And people bought them all. And then they got them, and they didn't have any transistors in them, and they were just like no boards in them or anything. And what the guy had done is he bought my stickers and slapped them on his junk and then put them on eBay and sold them. So you never know. You just never know. I'm not saying this guy's going to do that. I highly doubt it. He's so excited to have his stuff here that I highly doubt that. I'm just saying you never know. So I'm going to appropriately label this 8-pill repair because I don't know who the builder of this is. I believe it would probably be somewhere that somebody would come out of the Stickman camp, the way it was put together on the inside, but Stick wouldn't have done some of the things that were done in here. That guy built a good box for the most part. So I got to write these 2 transistors off. That's a hard $205 hit, or $210 hit, but is what it is. Here's the 2 that came out. I'm going to send them back with the amplifier, just in case you want them back. And then I'm going to hold on to this fan, because it's the only good one. The only thing that was good here was the LEDs in this thing. So we're going to file that in the trash. Let me know what kind of eyelet you need for this amplifier, and I will hydraulically crimp it and sweat it on there before it leaves here, so it's actually attached appropriately and not smashed on with a hammer. So, Mr. Fred, thank you. It's ready to come to you now. New fan, new transistors, bunch of new parts. Got her back rocking and rolling again. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck out here in the great state of Idaho. Come check us out. www.bbiamps.com. You can find me on Facebook, Twitter, Snapchat, Instagram, and right here on the YouTube Gargler. And if this is your first time watching this dog and pony show that I call my job, do us a favor. Click subscribe. Make sure to hit the notification button so you can follow along with all the crazy antics that we do over here. All right. I got to go, guys. I'm on to the next one. Bump, bump. From the base duck in Idaho, I'll see you. Bye.